Okay, so we'll start now. So let me share my screen again. So first of all, thank you very much all for attending, and there's a nice turnout, which is exciting. And dig the animated trivia background. Yes, we all like the animated trivia background. That's Yael's work. That's awesome. So thank you for joining for this Winglang plus Amazon Bedrock workshop. A little bit of kind of rules of engagement. You have the chat, so hi to you. I'm hoping I'm pronouncing it correctly, Tunde, and you can just write stuff here. From time to time, when I'm going to see it, I can show this. Besides that, we have a repo. This is the repo. The repo is on Winglang workshop workshops dash Bedrock. We have the Slack channel, and if we're good to go, let's start. Let's go over what we're going to learn here. Awesome. So what will we learn? So just making sure you're all able to see it. Is it good enough? Yeah, great. So during the session, we'll do the following. We're going to build a GitHub app and deploy it on AWS using Terraform. We're going to have an introduction to Amazon Bedrock, and we're going to have a guest star here, Eric from AWS, solution architect from AWS, is going to introduce us to Bedrock. We're going to use Amazon Bedrock resource from within Wing, and eventually we're going to create a GitHub app from scratch, developing it locally. There's some general resource here. It's a little bit about the language, the Winglang language, the in-flights. There's some cheat sheets where you can see different, basically different idioms of the language. And there's the wing libs, which is for any stuff that you want to install using Wing that is not part of our standard library. And there's the playground to play around with the language. But before we do this, I want to just kind of go into the future and show you what we're going to build. So we're going to build this application. The application is a GitHub application, kind of basically a GitHub bot that listens to any incoming pull request and correct the spelling, grammar, punctuation for any markdown file changes during the pull request. This is a GitHub app for me. I'm not a native English speaker. I make mistakes, and I want to improve. But until I do, let's have the assistant of an AI to help me with this. There is a demo here, a YouTube video, but I'm just going to show this live. So I already have a GitHub app with the application installed. So so this is the repo. This is the repo for that I'm using. On the left side here, we have the instructions, and on the right side, I'm going to have basically me doing the instructions. And we are going to have, it's a workshop, so from time to time, I'm gonna get off screen, and you're going to do the work. So this is the application. The application, as you can see in the setting, has already one GitHub app installed, English Grammar Fixer, that was developed by Karen. This is me. And let's see what happens when I use it. So I have this README file. I want to edit this README file. So editing this README file, I'm just going to delete this dot under the license, and I'm going to hit the commit changes. I'm not going to commit directly to the main branch because I want to create a pull request, because the application itself, the GitHub application, kind of is activated by pull request. So I'm going to create a new branch, and I'm going to propose the change. And then I'm going to create a pull request. So let's take a look at the file change. Basically what I've done, I deleted this dot here. So very, very simple. And if I wait a little bit, I see that the refresh button has arrived because there's a new commit. This commit was done by the application. The English Grammar Fixer still has my image because I haven't changed it. Let's take a look at the actual change here. And the change here is basically a fix in my English. So first of all, GitHub is spelled with a capital H. That listens and not listen to any incoming pull request and corrects with an S grammar and punctuation for any markdown files that were changed during the pull request. And then it adds back the dot. So we have an app that automatically created this. We can actually see This is the app on the left side. You can see actually the app, and we can actually look at the actual CloudWatch logs that happened during this watch. We can basically go here and kind of do a live trail on the app. So if I go back here and I close this pull request and reopen it, I should be seeing that Lambda function activating here and starting to run, because the application also reacts to changes in the Lambda. And here it is. So this is on the left side, we're seeing the actual Lambda function logs. On the right side, the app. And this is what we're going to build today. So that's it. That's pretty simple. So let's go back to Google here. So it will be clean in this place. In terms of the workshop session, we got the setup and prerequisites part that requires us to install the following stuff. We need to have Wing installed in order to function properly. We need to have an AWS account configured and the CLI installed. We need access to Amazon Bedrock foundation model, and we need ngrok installed and working. And what we're going to do now, before the next session will be that we're going to talk about why Winglang, and then introduction to Bedrock. So the first thing we're going to do, I'm going to give you about 10 minutes to go through the setup and prerequisite of this session. So I'm putting myself offline, and let's install Wing. And any question you have, you can post here or on the Slack channel. So we're going to take 8 minutes until the 20th minute. So we still have about 5 more minutes, but anyone having problems or any issues, came across any issues, either with installing Wing, with getting an AWS account configured with a CLI, having ngrok installed and working, or getting access to Amazon Bedrock Foundation, let us know, and we can help over the Slack channel. The most important part for you to participate right now is the access to Amazon Bedrock Foundation model, and of course the CLI. But if you're having problem with this, we're going to talk about Winglang, and then we're going to talk about Bedrock. So we're going to have time to help you out with this. So for those of you who've requested access for the foundation model of Amazon Bedrock, just FYI, it's a fairly quick process. You get a reply that your request is being handled, and a couple of minutes maybe after that's what usually happens to me, even less, you get a reply that you've been approved. Great. For those of you who haven't finished yet, don't feel bad. We're going to have more chances to wrap this up. The next phase for us in this on the agenda is talk a little bit about Winglang. A lot of you are community members, so we're going to make this quick, and also the actual kind of exercise of building the app will also kind of demonstrate why Winglang. But so I'm going to make this really, really quick, and I'm going to use this PDF for that. So why Winglang? So the first thing we need to know, we need to acknowledge that building serverless application is hard, and I've outlined 3 reasons why it's so super hard. The first thing, you have to know the intricacies of your designated cloud provider. One developer we've talked to quoted that said that he's using 60% of his time spending infrastructure, wiring infrastructure together. So if you take a look at Bedrock, for example, so you need in order to use Bedrock, you need specific IAM permissions on a Lambda function that will allow you to invoke the model. That's something that a developer needs to know when he's not using Winglang. And when you think about we want an API gateway to be connected to a Lambda, we need to know how to upload, or what the CI/CD process of uploading a Lambda function that does. You either need to know the Terraform implementation or the CloudFormation implementation, and that's a lot. And while serverless application infrastructure as code is wired together, the infrastructure itself takes a lot of time to basically understand how to wire up. The second thing, that even if you are fine with wiring, the turnaround for every mistake you're making or every test is you need to test stuff in the cloud. And we've talked with many developers, and one of the engineering managers wants to, we have some form of local developer setups, but most people just push untested stuff into staging and roll back. Someone says they're rolling back a couple of times a day because of this. So in order, this is the second problem. The second problem is you have to test stuff in the cloud. And the last problem is not about development, it's more about operating. Microservice architecture is how to set up, visualize, and operate. I want my developer experience to be like they're building a monolith. While basically, if you're using microservice architecture, if you're using a bunch of Lambda functions, pub subs, topics, SQS, DynamoDB, when you go to operate on your application, you lose the entire context of your application. You might be having some labels that indicate what this specific resource is actually meant to be doing, but in practice, you lose the application structure that is so important to understand what's going on. And that's why we've created Winglang. It's an open source programming language that runs on the cloud. It takes the infrastructure and the infrastructure part or the provisioning part and the application logic, and because they're already, the lines are blurry, we just put them in one unified language that can compile into Terraform, can compile into CloudFormation, can compile into any provisioning engine, and it can run on your local machine as well, and that's what we're going to see. It should be that's the 5 minutes gist about Winglang, and the next part for our session is introduction to Bedrock, where we're gonna join us Arik Porat, is a solution architect at AWS. Let's put him on stage here. Let's, and how?
Hey
Arik, how you doing, man?
I'm great. How are you?
I'm good. Thank you for joining.
You.
It's I know it's late, and I know you have small kids, and I kind of feel like we're gonna hear them a little bit, and that's okay. And thank you for being here.
Yeah, thank you for having me here. Hi everyone, my name is Arik. I'm a solution architect in AWS. I work with startups company, and in my role, I help my customers to build and design their systems on AWS. You can think of me as a trusted advisor for any technical issue or manner. And specifically, I specialized on machine learning and containers in AWS. So in the next few minutes, I'm going to do like a quick intro to Amazon Bedrock that we have introduced in 23. And basically, Amazon Bedrock is a fully managed service which offers a choice of foundation models. These are those large language models or LLMs that came into the world, into our world, and did all this great stuff. And we offer LLMs from leading AI companies such as AI21 Labs, Anthropic, Cohere, Meta, Stability AI, and also Amazon. And all of these LLMs, you can basically consume them in your AWS account, so you don't have to go outside to the public internet. So there are a variety of models that you can use for different tasks. So we have models for NLP tasks like text generation and question answering and text summarization, etc., etc. But there are also large language models for image generation. So we have Stable Diffusion of Stability AI, and we have Titan image generation of Amazon. And in addition, we also provide models for creating embeddings from text or for images. So basically, you can use this model to create embeddings, store them in some vector database like Pinecone or OpenSearch, and do semantic search using cosine similarity or other KNN methods. So what's great with Amazon Bedrock is basically that all of these models, you consume them using APIs. So you don't need to manage infrastructure. You don't need to, scale or provision EC2 machines. You don't need to do any training or use with GPUs. All is API based. You can think about it as a serverless service. that you consume using your favorable language of choice, like Python, for example. And let's jump into the Bedrock console and show how it actually look. So let me share my screen and give me some, I don't know, +1 that you can see it.
We can see. Thank you.
Okay.
By the way, Eric, you mentioned embedding. Do you mind touching a little bit what embedding is?
Yes. So basically, embeddings, it means that you take a text, for example, and you convert it to numbers. Okay, so you convert it to a vector of numbers, because machine learning doesn't know, you have like a text that you send to your LLM, to your whatever model that you use. It doesn't know about text. It knows to use numbers. So basically, everything that we use in machine learning, we use numbers for it. So the purpose of embedding is to convert this text to numbers, but it's not just a regular vector of numbers. It's a vector that represents the context, the attention of the words. So it has meanings. And if I take these embeddings, for example, of an image or a specific text, and I save it in some database, in a vector database, I can basically take other text or image, convert it to the same embeddings, use the same embeddings model, convert it to embeddings, and then do similarity check against to check how close these two vectors to each other. So you get better result, like if you want to do like search, opposed of doing like text search in all kind of the regular databases.
Awesome, thank you, man.
No problem. So basically, this is how the Bedrock console looks like. And you have here the menu from the left, and I will start with the providers. So you can see here all the providers that I mentioned, like AI21, Amazon, Anthropic. And if you click on every one of these provider, you can basically go and see what kind of models they offer. So for example, Anthropic, they offer currently like 4 models, and you can read about the models and the supported use case. You can read about the max token that it supports currently. Claude 2.1 support 200K tokens. It's very huge. You can basically send something like 500 pages of text to the model. Okay. From this, you can also see the end user license agreement. You can also see the pricing, and basically you can, go and check and see all the different models that are here that we have to offer. So from here, you can also, if you want to check a specific model, you can go and click and open it in a playground. Okay, so we offer basically a playground for chat, text, and image. You can go and play and examine to see what kind of result you can get. So for example, currently I'm using Claude 2.1. Basically, it's the latest model from Anthropic. And we can try asking me some questions. So let's try, what is the meaning of life? Let me copy that. Okay, and you can play with the temperature and other features, and you can click run, and you basically see the answer, and you can play with it in the AWS console. By the way, every one of you that have an AWS account can go and play and test it. Currently, Bedrock is available in 5 regions, so just go and play with it. So I got an answer, and you know what? If I want, I'm now able to compare other models. So I'm able to choose some different model. Let's take Meta, for example, Llama 2. Okay, and let's take another one from AI21. Let's take Jurassic. Okay, so basically I'm now able to write the same question to the chat, run it, and it will send it in parallel to the 3 models, and I can compare, see what kind of answer I get. I can see the latency. I can see the input and output token that I get for the models, and I can see which model give me the best results.
This is super nice because Eric, one of the things I struggle with when you're using the API, you have a different kind of prompt request response, and it normalized the request response, which is great.
Yeah, so basically you're right. Like the response are the API is similar, but the payload that you send to the different models might change from one vendor to another, because these are third-party models vendors that we use here. So yeah, it's easy to use, it's easy to play, and you can also do the same like with an image, like a text-to-image model. So we currently offer two options. You can take Amazon Titan, or use Stability AI, use Stable Diffusion. Okay, and you can just write something. Blue backpack on the floor. Okay, and click run, and basically it can generate image, and you can take this image, you can play with it, you can edit it, do whatever you want with it. Everything is on the console. Okay, so one important thing to mention is when you start with Bedrock, the first thing that you need to do is basically go here to the model access. Okay, and you need to choose, it will be in the beginning, everything will be unchecked, and basically you need to check every model that you want to use. Okay, you need to select, basically you can select all of them, and down below you can see that by selecting those, basically you are agreeing to the end user license agreement, and it also telling you that if you are consuming third parties models, the charge will be from the AWS marketplace. But this is like the first thing that you have to do when you are using Bedrock. Some of the other features that come in Bedrock. So one of the most thing that people ask is to be able to fine tune. So Bedrock basically also supports to take a model and to fine tune. So fine tune means that you customize your model to your own need, and maybe to get improve your model accuracy for a specific task, or maybe your model you want to it to be answered on some new domain that the model is not familiar with it. So there is an option basically to take several of these models and do a fine train for this job, and to be able to get a specific customized answers. Now I want to say a few words about security, because this is something that always pop up in all of our meetings. So as you know, security in AWS is job zero. Everything that we do, it starts with security. So it's important to mention that Bedrock is running on AWS. So all the models, the third-party models, are running in the AWS region, and it's running on a dedicated and isolated environment, so no one have access to it. And everything that you send, the token that you send, input to the input text that you send to the model, and the output tokens that you get with it, no one have access to it, even not the third-party providers. So it's only you, and if you do a fine-tuning job, only you have access to this model. And another thing is that Bedrock basically integrate with private links. So if, for example, you have EC2 running on your VPC, and you want to integrate, invoke Bedrock, you can use a private link to basically privately connect from your VPC to Bedrock.
Nice, very nice.
Yeah. So another new feature is that it became available now in reInvent. On reInvent is the knowledge base. Basically,
is that the one that you showed me? Sorry, Eric, is that the one that you showed me with the EKS, asking the EKS?
Yes, exactly. But you are telling them
just prepping them.
Yeah, so knowledge base basically allow you to do and manage RAG. RAG is retrieval augmented generation. And by RAG, basically, you have those large language models, but when you send them, when you ask them a question, the answer might not be updated to the relevant for current date. For example, if you ask the LLM, what is the current stock market of today, it will not know to give you an accurate answer. Okay, or if you have like specific data set or files like insurance policy that you have and you want to ask the LLM model and you get a specific answer through your data, so it will not know how to answer. So one of the features is basically to solve this kind of problem is to use retrieval augmented generation. And knowledge base basically offer it as a managed solution. So basically with knowledge base, what you have to do, you create basically, let's click next. Okay, basically you give it an S3 location, and to this S3 bucket, you upload your files. So it can be text file, PDF, CSVs, and so on. I took, for example, let me show the file. So I took the developer guide of EKS, the Elastic Container Service, okay, and I uploaded to S3. Okay, and then basically I will cancel it because I already did it. And basically you can, knowledge base Bedrock under the hood can take these texts, convert them to embeddings, okay, and save it on a vector database. So you can choose like Amazon OpenSearch, or you can use Redis Enterprise or Pinecone, or you can even use a Postgres with PG vector, whatever vector DB that you want, to be able to index these vectors. And after that, you completed this, and by the way, if you upload more files, they will be synced. And if you remove a file from the bucket, the data will be removed from the database. So after completing this, basically you can ask the model questions based on your text. So just for a test, for demoing, let's take a question. Okay, and I will open a new tab in the chat here. Okay. Let's pick Anthropic Cloud 2. Okay, and I will ask him which version of EKS are currently supported. Okay. So the model was trained, I guess, a few months ago, because the answer, you see, it's telling me, it's printing here like 120 up to 124. Basically, all of them are not supported. Like 124 became not supported from 31 of December. So all of this version, it gave me a wrong answer. So with the knowledge base, basically, I can ask the same question. Okay, let's select Anthropic, Cloud 2, V2. Okay, ask the same questions. Now I'm asking the questions, but I'm first, Bedrock will query it on the vector database. It will get the most relevant answer, and it will send it as a prompt to the Cloud 2 model. Okay, and you see that I get a better answer,
Nice.
Like with the most recent version that are supported. So 124 it still wasn't removed from the documentation, but it will remove soon. But basically, this is a way, that you are able to, enrich your model with more up-to-date data, or if you have like a private repository that you want to ask about it, it's one of the way to do it.
Nice.
And if this doesn't work, the other option are to do like fine-tune for your models.
Awesome. Eric, that's super awesome. That's kind of when I've learned a little bit about LangChain, that's in a way embedding and then asking. That's basically the way to do it. And it seems like this is the serverless way to do it. That's super awesome.
Yeah, and by the way, Bedrock also integrates with LangChain. If someone wants to work with LangChain, you can do it.
Right. And you can use a vector database outside the AWS, momentum database. Everything is open for you, but you also have the serverless approach, which is great. Which basically kind of takes away a lot of the infrastructure stuff away from you. That's awesome. Yeah. Eric, we're running out of time. I want to first thank you. There's a bunch of questions that I've seen on the Slack. Some people are having problems. If you can try to help us in the Slack, that would be great. And I hope you will be able to stick around here and go through the process. thank you again for joining us. Anything you want? Any last stuff you want to say?
No, thank you for having me. It was a pleasure. And yeah, I will stick in the Slack and I will answer some questions.
Awesome. Thank you very much, Eric. Great. So going back to the process, so we've just got introduction to Bedrock. And again, if you have any questions, just tag Eric in the Slack channel. And for the next sessions, we're going to be starting with using Bedrock in Wing. So we're gonna install it and use Bedrock, and then we're gonna create a Wing app, a GitHub app, and then we're gonna use Winglib GitHub to implement the app, and then we're gonna take back the Bedrock and use spell checking and deploy to AWS, hopefully in time. So let's start with session number 4. I'm gonna go quickly over this process. And then I'm going to give you a couple of minutes to do the same. Let's start. So as you can see, I have the instructions here on the right side. I have VS Code running. I already have everything installed, and I need to create. I already have a directory. So let's just do an npm init. That's interesting. I lost my copy-paste capabilities. I'm not sure why. So we have a package JSON, and we want to install. Okay, great. So we want to install Winglib's Bedrock, which is basically an npm package that is. Just 1 second. I have an annoying mosquito on me. Okay, great. So I've installed Winglang Bedrock, which is basically kind of if you're familiar with NPM, it's just add this thing and created a node model for Winglibs with the Bedrock code. Winglang is compiled into JavaScript and is can work with JavaScript so that's the first thing I've done. And now we want to use this. So I'm going to create a file, bedrock.main.w file. Let's create a new file. And we're just going to copy paste. Let's do this. Let's do bring cloud. And now we're going to bring Bedrock. Because I've installed this already, there's no compilation issue. And we don't need the files right now. And the first thing, let's create a new resource, a new class, the Bedrock model, and give it the Anthropic cloud is 2. And let's save this. And now I can do 2 things. I can do wing run here in order to see this, or I can also click on this thing and actually see that I have my application here. Not a lot I can do with it, just an application. What I'm seeing on the right side here is the simulator. Let's close this for a second so it won't interrupt us. Great. Now we want to create a new cloud function and give it an in-flight. And the in-flight closure should accept a topic. Great. And in this in-flight closure, let's take a look at the code we have in front of us. So we have the model itself. The in-flight function, in-flight means that this code is going to run on the cloud. So this thing basically turns into provisioning a Lambda function, for example. The fact that we're calling new cloud function, in AWS, it will provision a Lambda function. On my local host, it will just create a function. And the actual function that's going to run in the cloud is this in-flight closure that accepts a topic. And then it invokes the Bedrock model with the prompt, tell me a joke about, and some payload that is relevant for that specific model. Temperature is how creative it is. And once I get the result here, it's a JSON, as you can see, and I get the completion from the JSON, and I take it as a string, and then I log that joke. So what I'm gonna do right now, I'm gonna run this wing run on my local machine. Let me make sure it's saved. Wing run bedrock.main. And let's see what I have here. So I'm going to get this a little bit bigger. Okay. So we have let's get this a little bit bigger. Great. So we have a cloud function that we saw in a second ago, this cloud function. And we have the Bedrock model. And I can call it with a payload. So tell me a joke. Let's go back to the code. Tell me a joke about sales and developers. Okay. So I'm going to hit this. I'm going to hit the invoke function, basically activating the Lambda function. And the localhost simulator of the implementation of this Bedrock module is actually proxying the actual questions to, prompts or requests to AWS. And I get a response here, and I can see it here. Let's read this. Here's a silly joke about salesperson and software developer. Wow. It's a little bit long. A salesperson and developer walks into a bar. The salesperson says, I'll have a beer and whatever my friend is having. The developer says, I'll take a beer. The salesperson says, great, we'll take 2 beers. The developer says, but I already ordered. The salesperson interrupts and says that the bartender will take 4 beers total. Okay. So I don't know if AI will take developer work, but it's not going to take comedian work. So, but this is basically Bedrock. We've really easily just written this line of code, and I can take this code right now, and I can do wing compile this to TF AWS, and give this file, and the output of that will be a Terraform file with all the stuff that is needed, including the actual kind of invoke function. So as you can see, the Lambda function needs an IAM policy that needs an invoke model on the foundation model of Anthropic. All of this is something that comes out of the box, so I can just take this Terraform file and basically deploy this to AWS. Now, as you can see on the left side, we have all this explanation, and then we have a challenge. And the challenge is, are you able to create a prompt that will accept a markdown file and return a markdown file with perfect English? So what we're going to do now, we're going to take 10 minutes to go through this process, and just to make sure that everything is working for you. And if you are able to get to the challenge and make it, I would love to hear how you've done this, because it's a hard task. So I'm putting myself on mute, and we'll be back in 10 minutes. So one thing that come up from the Slack channel regarding the model access, you have to make sure that your account has billing configured properly. So because because this thing costs money. So for people that were not able to get access, that might be the case. Thank you, Eric, for that. We'll wait 2 more minutes before we move to the next session. Okay, so this is fairly simple and fairly powerful. Just as a reminder, we've written this 20 line of code, and we're able to access Bedrock, and we can run this locally on our machine, and we can also deploy this to AWS. In this example, we've created a cloud function, a Lambda function in AWS, and invoked this and got all the permission. We will later use Bedrock, and if you guys were able to if you're able to complete the challenge, please post this on comments here or in the Slack channel. But the next step is for us to create a GitHub application. So let's go to the next step. Great. So create a GitHub application. This is a fairly easy step. It's a step-by-step guide to how to create a GitHub application. I'm going to do this with you. I'm going to go into GitHub, and I'm going to create a new app. So I went into the setting apps, and I'm going to create a new GitHub app. I'm going to call it my English editor, and I'm going to put dev inside the parenthesis. No, sorry. Yeah. So because this will be my local host, my development GitHub application, I'm going to have another one for the one I'm going to be deploying in AWS. It requires a homepage URL, so I'm just going to give it Winglang, and I need to trim. There's no other trailing white spaces, and then I'm gonna. The callback URL is this isn't authorization because I'm going to use it for my application. This authorization part is not important, but I'm going to go to webhook. The active is important. The fact that I want to get events for any webhook is triggered, and then I'm going to put a URL. Now this application is going to run locally, so I have no idea what URL, and also GitHub will not able to basically interact with an application that is running locally. For that, I will be using ngrok, which is something that was in the installation instructions. We're going to see this later. But for now, I'm just going to put here a placeholder. So this will change. I need a secret, so I'm going to put a bad secret here. This is the webhook secret. And then I will go to the permissions. The application needs basically two types of permissions. This is repository permission. We need to be able to basically kind of commit code, and that's the content. So repository committing branches, downloads, releases, and this is, I'm going to need the read and write permission. And we need pull request permissions. So let's look for the pull request permissions. So labels, assignee, and we're going to take a read and write permissions for this as well. And the next thing we need to do is subscribing to events. And we only care about two events right now. We care about pull requests and pushes. Great. And going all the way down, I'm going to click the Create GitHub App. So this is fairly simple. Let me do this. Name already taken, of course, because I've already did this. My English fixer. Okay. Going all the way down, I just want to make sure that nothing is left here. Okay, so I still have the webhook. Great. Now the app and the ID is saved. Let me just save this ID. I'm going to need this in a second. And I need to go down, all the way down. The webhook was missing, so let me just make sure I have this webhook. Let me save this change. The webhook secret is important, and I need make sure you have that webhook secret. It's something that if you don't have it, you're gonna get an error. And then I'm gonna create a private key. I'm gonna generate that private key, and that private key is automatically downloaded into my computer. There's no need to look at it right now. And once I do this, I need to install the app. In order to install the app, I need to create a new app. So let me go back to GitHub, to my account. Let's create a new app. I'm going to click the new repository, and I'm going to call the repository testing dev mode, testing Bedrock dev mode Delmi. Okay, great. So it's a long name. Let me save it. I'm going to have a README file, and I'm going to create a repository. Great. Now the repository is created. I need to go back here into my English Fixer dev, and I want to install this app. So I'm going to install app. I'm going to hit install, and I'm going to give it just one repository. Delmi. It was dev mode. Here, testing Bedrock dev mode. I'm just giving the GitHub application permissions for a single repository that I just created, and clicked install. And at this point, I have access to this application. And that's it. Basically, if I go back here and I look at the setting page and I look at GitHub apps, now I have my English Fixer dev. So this is all that is required to create a GitHub application, but that's not enough. Now we have the app ID, private key, and webhook secret. We need to create the app. So I'm giving you 3 minutes to complete this process. It's pretty straightforward. And let me know if you have any questions. Great. So for those of you who already have a GitHub app, that's great. If not, you can just complete this. I see that some people have issues still with the access model, but Eric is helping us with this. Thank you, Eric, again. The next step is, now we have a GitHub app, but we need to implement this. And when you think about the GitHub app, we need an API gateway with basically kind of a webhook request, and we need to respond to this request. So let's take a look at what we need to do. Great. So in this section, we'll implement a GitHub app that listens to PRs and modifies the change markdown files. The prerequisite here is, again, please make sure you have ngrok installed, just to see if I have ngrok here. I have. And ngrok is used by the simulator implementation of the GitHub app. So we'll see this in a second. The GitHub app. We will use Winglang GitHub module, which uses the API gateway, and the Probot framework to create an easy way to develop, test locally, and deploy GitHub application to production. So the first thing we need to do is install the GitHub application. This will change our package.json. Let's take a look here. It's quite large. Okay, great. Now we have GitHub installed. We can look at this. We can see that in our null model we have Probot. We have a lot of other stuff that came in order to make this work. And the next step is we're going to create a new main file. So we are not going to use the existing Bedrock file. We're going to create a new main file. Let's do it. Great. And very, very quickly, we're going to bring GitHub here. Nice. And let's see what we can do with GitHub. So we need to do let markdown equal GitHub, new. I want to create a new GitHub resource or a new GitHub class in pre-flight. And I have the Probot app here. Now, as you can see, there's an error here. And the error that I'm using, I'm missing some arguments. So let's see what I'm missing here. Interesting. Okay, great. So I'm missing a credential supplier. So let's create this one. Let credential supplier. And I'm missing an on pull request open. That requires an in-flight function, and an on pull request reopened. So the implementation of our GitHub app is still really, really kind of limited to functionality. You can open bugs and requests, and you can add more code to it. We'll shortly implement this. With PR was opened, because this is a request, and let's do log PR was reopened. Great. Now we need to give a credential supplier. The credential supplier, as you can see here, is an iProbot credential supplier. So because the GitHub app needs to know what's the actual app ID, the private key, and the secrets. So let's create a class called let's create a class called simple credential supplier that needs to implement github.i. Let's get more room here. iProbot credential supplier. So what we're doing right now, new simple credential supplier. So let's review this. Now the Probot app is happy because we gave him an interface or a class that implements the interface of iRobot credential supplier. The problem is that the compiler is still complaining that I haven't implemented 3 functions here. Let's get this thing away from here. The function that I haven't implemented is get private key, get webhook secret. So let's do this. So I'm just gonna copy paste this, the implementation. And I'm gonna go back to my GitHub app, to my English English fixer. Okay, great. So I have the ID here inside my English fixer. So let's copy paste this ID. I have the webhook secret. I've used this is a bad secret. What was I think I've used this is a bad secret. This is a bad secret. And I need a private key. The private key, in order to, I have a file with a private key. So I'm gonna basically read this file. In order to read this file, I need to bring the FS. Bring is, if I haven't mentioned this before, bring is our file system. And I need the path of the file. This is the file here. Let me just open this in Finder. I'm going to drag this here. And now I'm going to put the path for the PEM file here. Now, what will happen basically in this example that I've created a very simple credential supplier. It's not good enough, and I'm going to talk about this in a second. But it's good enough for what we need right now, because the Protobap app will have the secret, the ID, and the actual content of the PEM file. The next thing for us to do is 2 things. Let's take let's actually do wing run. Wing run GitHub main app. Now this, if you look over here, we're looking for the webhook. This is the webhook URL. On the left side, we're seeing the application, and it says that the URL is updated. So let's hit the refresh here. As you can see, the webhook URL was updated to what's happening on the left side. So when I am running my application, let's take a look at the application actually. When I'm running my application, it automatically updates the webhook. So as you can see, there's an on-deploy function here that will automatically update, and there's ngrok here that basically makes sure that, as you can see, the URL here is an ngrok free URL, because I'm using the free version of ngrok. So now I have my application is connected to a URL that is publicly available on the cloud. If I'm going to go over here and change the code a little bit, even just a semantic change, this will rerun the flow. And if you look at this number here, when I refresh, it's going to change. So every refresh, the localhost implementation of our GitHub app is automatically updating the server. So this is part of the solution. The other part that I want to show you is, let's go to the actual application that I've got installed. Let's go to repositories, testing Bedrock dev mod delmi. And now let's edit this README file. I just need to open a pull request. So I'm going to commit. I'm going to create a new branch. And I want you, once I do this, I want you to focus on the side, on the log, no logs here, and propose a change. And when I create the pull request, why can't I see the change? What did I do? Commit change, create a new branch, propose change, sorry. And now I'm going to create a pull request. And on the left side, I should be seeing the, oh, PR was open. Yes, the log that I have here, PR was open. And if I And if I close the PR, if I close the PR, let me clean this again. Now I should be seeing, and reopened it, sorry. I should be seeing PR was reopened. So this is just a proof that I have those two sides connected, the side of the actual GitHub that is on the cloud running on Microsoft servers, and my local implementation that includes a cloud API gateway. That cloud API gateway has, if you take a look at the routes here, has a post webhook route that basically using ngrok is being activated. So going back here, we are able to see this in action, and now you have a challenge. And the challenge is follow the Winglib's GitHub README file to see if you can replace all changed markdown files with an uppercase version of them. So you have to go through the entire process, but instead of using the code that doesn't do anything, on pull request just log something, there's a hint on this README file how you can change all the markdowns to do it. So I give you 7 minutes to do it. It's mostly copy pasting. Let us know if you have any issues. I'm putting myself on mute. Thank you. Okay, so right now we have in this section, we're basically going to use the Bedrock model in order to actually change the language. So we're gonna take the stuff that's happened on the README file. So this is the code that actually goes through 2 commits and extracts the files that were changed in the commit. So you can see we're comparing 2 commits. We're comparing commits. We're using the OctoKit package for this. We're comparing 2 commits, the base and the head, based on what the pull requests have, and then we're going through the compare data commits, and we're taking the content, and we're checking whether the file name ends with markdown, and if the file status is either modified, or if it's added, or if it's changed. If it is, we're adding it to a list, to a set, and then for every file name in that set, we're getting the content of the file. This is the file content. The file content is in base 64, so we need to decode this using the util, Winglang util, base 64 decode function. And then the next thing we want to do, we want to correct its English. So we're going to have a commit for every file, and the commit message is correct the spelling, grammar, and punctuation of the file name, in file name. And the content is util.base64 encode, because we need to do this in encoding, and we're going to call the correct function on file content. The correct function is an in-flight function. It's an in-flight function because it runs on the cloud, right? It runs on the cloud. Let's take a look at the correct function. The correct function goes and it invokes the cloud model ID with this system prompt, correct the English, including typos, grammars, punctuations, in the following markdown text, reply with corrected markdown text, delimited, and delimit the text by the body tag. So this is important because every model that I tried kept giving me kind of the prefix of the questions. So once I've done this, we invoke Cloudy with this prompt. We give it max token to sample big enough for this. And again, this will not scale for bigger file, and we need to solve this. And then in the result, we're getting the completion as str, and then we're splitting this based on the body tag. So I'm going to split this and take the second element based on body, and then the enclosing body tag, and take the first element at 0. This will output R. Let me save this for a second. And let's take a look at what's happening in my over here. Okay, so now I have a problem. There's an unknown simple credential. Great. Oh, I've deleted the credential. Great. So let me do some okay. Okay, I'm just copy pasting this Great. So I didn't want to delete this. So this is the simple credential supplier that takes this file. I'm going to save this right now. Now let's take a look over here. Get more space here. Now we can see that the actual function. Now we can see that the actual function is using. I mean, there's a usage to the. Interesting that we don't see this, by the way. I would expect to see. Yeah, I would expect to see a line here, but we're not seeing it. It's interesting. We should open a bug about this. I would expect to see a line between the function inside the API gate, from the API gateway into the model. So I'll open a bug on this. Let's go back to demoing this result. So this is some text that have issues. Okay. I'm going to commit this into a pull request. I'm going to clean this log on the left side. I'm going to propose this change. I'm going to create the pull request. I should be seeing stuff happening here, hopefully. Let's see. Okay, great. So now I see that it is invoking the entropy function, and there is the result of the completion. And I have another commit here. Let's take a look at this commit. This happened to me from time to time. It basically destroyed it. Let me. There's some problem with my prompt. I think I think I need to play with the temperature of the prompt, because this happens from time to time for me. This is some text which have an issues. Let's see if this is going to work. What? Commit, create, propose, create pull request. Let's wait for the update here. It's invoking the module. It's still, there's a problem here with my, it's still going to have the same tag problem. I will have to look up why this is broken. Something probably, maybe there's something wrong in how I copy pasted this thing. The actual, maybe like this. I don't know. I will need to check. I won't do this now because we're running out of time. Another important thing here is that this solution that we have here is, let me close this thing. This solution that we have here, let's see how it treats the, this simple credential solution basically is reading this file, which means that the code that I am, the code that is bundled into AWS contains this secret, this secret and this PEM file, which is very, very bad. We don't want our Terraform or JavaScript to include secrets. We want to use SSM for this. So the next step for us is, and this will be homework for you, is to use secret on the simulator instead of using this code. After this will be working, now the application is actually ready to be deployed on AWS, because we have to use secret. And unfortunately, we won't have time to do this. And then the last part of this session will basically to deploy to AWS which is pretty straightforward. You can just jump over here. There's the actual code that uses the secrets instead of reading files. But you have to basically kind of create secrets on your secret manager to do this. And eventually you just need to do Terraform apply to deploy this. And in the process, and that's it. You have your own GitHub application that uses Bedrock. So let me remove this for a second. This is it. We've reached the end of our time, and we've only missed kind of 1 session and a half. I want to thank you for participating, for all the questions. I want to thank Eric again for the time. And I'm looking forward to seeing you on our Slack channel. Let me know if this was helpful, and subscribe for the next one. Thank you very much. Bye-bye. So first of all, I haven't closed the stream because I see people are writing comments, and I want to thank you for participating again. So I give us 5 minutes and then I close the stream. Thank you very much.